Right, let's talk about identifying key features of graphs. So in this video, we're going to identify the key features of the graph of a function in context and evaluate a function using a table or graph. So let's start with a little opening exercise. Again, reviewing that function notation is when you have f and then it's going to be the input so we normally think of f of x is equal to y, or f and then the input is what's going to be inside the parentheses and it will be equal to the output. So if we look here, right, f of -3, so I would look at my x-axis because that's the input of the function, and so I look at -3, okay, and then I have to find the y value when x is -3, so I look at the point and it's right here, so that would be, the y value would be 1. So f of -3 is 1. Right, you can do that with f of 0, so now we look on the x-axis at 0, find the y value of the graph, which is right here, so that would be -2. So I'd like you guys to try C and D. Pause the video, try that. All right, so I'm hoping you gave that a shot. So f of 1, you would look here, the x value for 1, you get the y value of -1. F of -4, so again, look on the x-axis at -4, and where is the y value there? It is at +2, and f of +4 is also at +2. All right. So then it says, what is x when f of x is -2? So now when you're asked a question like this, it's giving you f of x, or the y value. So you look on the graph, where is the y value -2? It's -2 right here when x is 0. So you can try a similar problem. What is x when f of x equals 1? Be careful here, try this on your own, but you have to tell me every x value where f of x is 1. So pause the video, try that. All right, so I'm hoping you gave that a shot. So where is the y value equal to 1? Well, we see that it's equal to 1 here, and it's equal to 1 here. So there are two solutions when x is equal to -3 and 3, +3. Because both of these x values give me a y value of 1. Good. So we've talked about this. Where is the graph decreasing? Well, the graph is decreasing when the y value is going down from left to right. So if I highlight that, it would be from point A to point C. So from A to C. And where is the graph increasing? Well, from C to E, my y value is going up, so my graph is increasing. So from C to E. And then you can ask yourself, where does the graph have a maximum or minimum? Or does it have either one? So we see that, right, this graph definitely has a minimum, right? It looks like C is the minimum because it's the lowest point on the graph. It is the lowest Y value. And, well, maybe this graph keeps going, so maybe we don't have a maximum, right? So, if you want to write here minimum, you can think of as the smallest Y value or the lowest point on the graph. And the maximum, well, that would be the largest Y value or the highest point on the graph. So then, we can ask other questions like, does the graph cross the x-axis? So does this graph cross the x-axis? So the x-axis is here highlighted in yellow. And I see that, yeah, it does cross. It crosses at point B and point D. So yes, it crosses how many times? Twice. Or maybe just, say 2 times. And then we could list those points as ordered pairs. So remember, coordinates are always x comma y. So if I look here, it's going to be -2, 0, and 2, 0. So we're going to define these as sort of this math vocabulary word, right? The points where your curve or graph crosses the x-axis are called the X-Intercepts. Right? And similarly, we can ask, where does the graph cross the y-axis? So, crosses the y-axis. Well, let's see. Looks like it crosses again at point C. Crosses y-axis at point C. And we could give the coordinates for that point again in x, y. So the x value is 0. The y value is -2. So 0, -2. And, just like we called where the graph crosses the x-axis, the x-intercepts, we're going to call the point that the graph or curve crosses the y-axis the y-intercepts. All right, so you can, pause the video at any time if you need to write stuff down, but we will continue. So let's just define kind of our key features. So the maximum is going to be the highest y value or the biggest output. So this is going to be kind of all of the key features that we'll talk about. And these key features help us analyze the function. And some of these key features we've already talked about. So maximum, highest y value, biggest output. minimum would be the lowest y value or the smallest output. X-intercepts are where the curve crosses the x-axis. Y-intercept, where the curve crosses the y-axis. And we've talked about where the graph is increasing, decreasing, or constant, but just to remind ourselves, right? Increasing is the parts of the curve that go up from left to right. Decreasing are the parts of the curve or graph that go down from left to right. And finally, the parts of the graph where the graph neither increases or decreases are called, it's called constant. So those parts of the graph where it's not going up or down is called constant. All right, so let's look at one example, and then we will kind of leave the rest for you guys to do. But so if I look at this graph, f of x on the right here, I can identify the maximum. So I could look, again, let's kind of actually keep this right here so I can see. So maximum, highest value. So I see point E is going to be my maximum. So it's E, and let's see, it looks like it's at about 7, 90. If I wanted to write that as an ordered pair. Looks like I do have a minimum at point B. So that would be at 2, 0. So, an x-intercept can sometimes cross the x-axis, but it could just touch the x-axis. So if we want to think about x-intercepts, I actually see two of them. I have it touches or crosses here, and it touches or crosses again here. So I have B and F. Y-intercept would be where my graph crosses the y-axis. So right here at point A is where my graph crosses the y-axis. And then you can think about where the graph increases. So looks like I'm increasing from D to E, but also from B to C. So I have sort of two intervals or chunks where my graph is increasing. So B to C and D to E. Then I can think about where is my graph decreasing. So my graph is decreasing from A to B and also from E to F. So I am decreasing from A to B and from E to F. And finally, where is my graph not decreasing or increasing? So where it is flat. So constant, think of flat, not increasing or decreasing. And looks like right here from C to D. C to D. All right. So I will kind of end it there. I'll scroll down. So if you would like to look at example 3 and try it on your own, you can. But otherwise, I will see you in the next video.